Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Point Proven by Oscode. And here are the rules. We have Chaos Construction rule set, where we need to divide the grid into 9 regions, each consisting of 9 orthogonally connected cells. And fill all rows, columns, and regions with the digits 1 through 9 without any repeats. So, for example, this could be a valid 9-cell region because it's all orthogonally connected, which means you can get from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. Right? To get from here to here, you just go through edges this way and you will get to that cell. This is not valid as a region, and this would not be valid as a region either, because for get to from one of these cells to any of these cells, you have to either go through a corner or you have to go outside of the region to do that. Let's see. Yeah, so that's how chaos construction rule sets work. We have arrows, where digits along an arrow sum to the digit in the attached bulb. So, for example, if this were, say, let's say I'd use this. This were 2, 2, and 4. This digit would have to be an 8. Because the remaining digits, so the digits on the arrow must sum to the digit that's in the bulb. A digit in an arrow bulb indicates how many cells in its own region can be seen horizontally or vertically, and vertically from the bulb, including the bulb itself. Other regions block vision. So a valid example of this being 8 would be 1, 2, 3, 4, 5, 6, 7, 8. So this would be its own region, and then these would be boundaries here. So yeah, this is an example of how the arrow bulb works, right? Because it sees itself 1, 2, 3, 4, 5, 6, 7, 8 cells of its own region, right? Horizontally and vertically. And again, so if you could not have something like this, I guess. You could not have something like, say, this. I think this is too large anyways, but it could not be something like this, because this would see 1, 2, 3, 4, 5 cells in its own region, and would not see any of these cells because it's blocked by some other region here. So that's how arrow bulbs work. And we have arrow tips, where digits on an arrow tip indicate how many cells in its own region can be seen in the direction pointed at by the arrow, not including the arrow tip itself. And again, other regions block vision. So if this were 2, these would all have to be the same region, because this region sees 2 other cells in its own region in that direction, right? If this was 1, then it would just obviously be just this 1 would be the same region as this. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, let's start with the arrow points and figure out what they can be. This can point to 1 or 2 at most. This can also only point to 1 or 2 at most. This could be pointing to 1, 2, 3, 4, 5, or 6. So this is 1 through 6. This could be pointing to 1, 2, 3, 4. This can only be pointing to 1 or 2 at most also. That eliminates 1 and 2 from the rest of the column because of the 1-2 pair. So this must be pointing to 3 or 4 at least. 1, 2, 3. 1, 2, 3, 4. This points to 1 or 2 at most. So it has to be 1 or 2 here. Which means this can't be 1 or 2. It's 1, 2, 3, or 4. So we have a 3, 4, 3, 4 pair here. Interesting. This can point to 5 at most. So 1 through 5. Huh. Interesting. This cannot be 1 or 2 because of the 1-2 pair in the row. This can't be 1 or 2 because of the 1-2 pair in the row. So this is at least 3. This could be 1 and 3 at minimum. So that would be 4. So this is at most 5. This is at least 3, 1, and 3, which means this is at least 7. So that's 7, 8, or 9. Let's see. This has to be at least 3 again. So this is at least 4. 4 through 9 here. This could be 3 through 8. Huh. Okay. This is at least 4, because you have a 3 at least here. This cannot be 4, because we have a 3-4 pair in the row. This can't be 3 or 4. It could technically be 2. It could be 1 and 1. No, it can't. Well, it could. Okay, no. If it was 1, 1, if this is 2, this is 1, 1. This is 1, 1. So then this would be, oh, I guess that's possible. 2 and 2. So it still could be 2. 2, 5 through 9 here. This is at least 3 here, and then 1 here at least. So this is a 4. Okay. This is at most 3 here. So this is 1, 2, or 3. This could be 1 through 8, 1 through 8. So these must be the same region at least. And these must be the same region at least. I'm going to make it yellow and pink. This has to have at least 3 of the same region. Interesting. Can this ever be greater than 5? Oh, I guess it could. Yeah, it could be just these. Well, does that work? 2 kind of works. 5 could work very well. So 1, 2, 3, 4, 5, 6, 7, 8. I don't think 6 could work. 1, 2, 3, 4. It could go like this, right? So 1, 2, 3, 4, 5, 6, 7, 8. 7 could also work. 8 cannot, I don't think. So it has to be part of the pink or the yellow region if it's 8. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Yeah, so it cannot be 8 or 9 here. So this is 2, 5, 6, or 7 there. These are guaranteed to be in the same region. These are guaranteed to be in the same region. These are guaranteed to be in the same region. I think these have to be different, right? Can it be part of pink? 1, 2, 3, 4, 5, 6, 7, 8, 9. No, they cannot be. So this is part of that region there. I'm going to make that red. So this cannot be part of yellow also. This cannot be part of yellow. 1, 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to make that blue, I guess. That's interesting. Unless this is 1, these are all part of the same region. Actually, so then we should make that orange. We know these are part of the same region. Can this be then part of the pink region? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, but the problem is this has to be at least 5. And it'll only see 3 cells if that's the case. So these have to be distinctly different regions. Let's draw the border around the entire grid. These are definitely distinct regions. So it could technically be part of dark, but it's probably going to be part of this blue region. Interesting. Again, this can't be part of the pink region, so we're going to make that green. It cannot be part of the yellow region either, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nope. So it's not part of pink, it's not part of green. It could be part of... Green could be part of gray. We don't know. Actually, let's make this light. So this is definitely not part of pink. So orange is either part of dark or it's part of blue. That's interesting. Because it cannot just be 1, 2, 3, 4 here. It has to be at least 5 that it sees. So it's part of blue or it's part of dark, but we don't know which. This is likely part of pink or part of yellow. Can this be both 2s here? Yeah? This would be 1, 1. This sees 7, 8, or 9. Can it see the pink here, is the question. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No. So it could be see only 3 cells this way. Okay, so this will make a green again. This is definitely light. So it sees at most 3 cells this way. 4. So this must... Okay, maybe we'll make it green. It can see 3 cells this way at most. 1 cell more that way. So it must see, guaranteed, 1, 2, 3 that way. So this is green. Could be part of light. Or this light. We don't know. But it's guaranteed to see 4 this way. It could be just this, though. That is possible. Okay. This is interesting. Okay. If this is not part of blue, can it be part of both of these, is the question. 1, 2, 3, 4, 5, 6, 7, 8. Yes, it could. Huh. So this could all be one region here. Can it, though? 1, 2, 3, 4, 5, 6, 7, 8, 9, yes, it could. But it would specifically have to be 2 pointing that way and 1 pointing that way. That's interesting. And what happens if that's the case? 1, 2, 3, 4, 5, 6, 7, 8, 9. It would have to be at least 3 this way. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. This would have to be 3 that way, which means this would have to be greater than 4. And it can't be greater than 4 because it would be blocked that way. So I don't think it can ever be blue and dark. Right? The only blue and dark combination would have to be something like that. And then this would have to see 2 because one of these has to see 2. Right? This could work though. We don't know. Hmm. Huh. So say this was 3 and so say this was 1. Then therefore it's not part of blue. That's interesting. So if this was 1, that means it's part of dark. So this is all orange. This would have to be 2. So then we know these would be orange, technically. Or I guess these would be dark. One, 2, 3, 4, 5. We have 6, 7. We could have 6, 7. 1, 2, 3, 4, 5, 6, 7. You could technically do that. That would work. Therefore, this would be 1. This would be 1. And this would have to be 2. So these digits are the same. I think in general, these digits have to be the same. These can't be different digits, right? If this was 1 and this was 2, that would eliminate all possibilities for that cell. Yeah. So it could be 1, 1, and 1, all adding up to 2. That's a possibility. It could be 1 and 4 adding up to 5. It could be 2 and 3 adding up to 5. 1 and 5 adding up to 6. 2 and 4 adding up to 6. Or 1 and 6 adding up to 7. And 2 and 5 adding up to 7. So those are the possibilities. And these must be the same. They must be the same digit. Because these are definitely the same digit. They add up to different digits. That if these are different digits, that would eliminate all possibilities for that cell and that cell. And these are the same digit then because they add up to the same value. So if we try to have a 3 or a 4 here, it doesn't work because these 3 or 4s are different values. But if we try to have a 3 here, this must be a 3, and that would eliminate one of these from being a 3, which is impossible, because then both of them would have to be 4. And the same thing with 4, so this cannot be 3 or 4. Interesting. So this must be either 1, 1, or it's 1, 5, 1, 6, 2, 5. So this cannot add up to 5 here. Then this would be 6 or 7 here. Huh. Interesting. This has to be... it could be 1. So this is 1 to 5 to add up to 9 at most. What happens if it's 1? Okay, so if it's 6, then it has to connect, right? Same with 7. It has to connect to one of these. Because it can only get 5 without being part of the same region. But 2 kind of works also. The interesting thing, though... Oh. Does that work? I don't think 2 works. If this is 2, this is obviously 1, 1, 1, 1, right? That forces this to be 2, and this to be 2. How does this actually form a region? I don't think you can, right? This only sees 2 in whichever direction, so it can only go one way here, and then it's stuck, because it can't be part of pink, because if it's part of pink, well, maybe, hold up, maybe it could be part of yellow, or pink. Maybe that does work. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6, 7, 8. It does work. But it has to be part of pink or yellow, if that's the case. Interesting. So either way, then this is part of pink or yellow. If it's 2, that means this is 1 and 1. But it could be part of pink or yellow by exiting out this way. If it's 6, obviously it has to go be part of one of pink or yellow, period. Okay. Huh. So what happens if it's 2? Okay, let's try that. 2, 1, 1, 1, 1. Therefore, this is 2. This is 2. This can't be 1 or 2 because it sees the 1 and the 2 here. So this is 3, which forces this to be 3, 3, 3, and 9. That's interesting. This can no longer be 3. This can't be 6 and 3 adding up to 9, so this would have to be a 4, 5 pair here. This one, so these would be the same region. This can't be 3, this must be at least 4. That's interesting. This can't be 1 or 3, so orange must be part of this blue region. Because it can't be just 1. So therefore, these cells are all the same region. We'll make that orange. It cannot be 2 here. This can't be 2 here. So this sees at least 4. This sees 2 that way. This sees 2 that... we have a contradiction. Right, we have a contradiction here. Because this would be light and light. Seeing these have to be the same region, which would be part of the same region as green, which does not work. Because then this would not see 9 cells, and that would fail. So, we know it cannot be 2 and 1. So this is 6 or 7 here. This cannot be 1 then. This is 5 or 6 this way. Again, it could be 2 and 5. So the problem here was that basically this had to be 1, 1, and that forced this to be a 3. And since this was 3, that's 3, 3, and 3, that's 9. It would have to see all 9 cells, but this would have to go 2 that way. Okay, what happens if this is 1, right? If this is 1, that means this is 2. This is 1, this is 2. That means this has to connect that way, right? So these are green to match that. Because it has to connect that way. If that's the case, this does not see either of these cells. And the problem is, well, it could connect that way. No, it can't. So if we try to have 7 this way, and it connects this way, this cell is not part of a region, which is not allowed to happen. And if we obviously connect that way, then we have 3 cells which are outside of the range of this bulb, which doesn't work. Because this has to be 7, 8, or 9. So we've proven this can never be 1. So this has to be 2. So since this is 2, this is 1. This obviously can't be 1 here. This can't be 1. This is 2. And this is 1. So this is a different region. This is red and red, though. And this is dark and dark. Therefore, to add up, this must be 2 and 5. So we have 2 and 5, 2 and 5. This adds up to 7. Therefore, this can't be 7 here. It's yellow or... So this is separate regions. This is at least 8. And this can no longer be 5 here. Because you only have 1 degree of freedom, right? It could be 4, 2, and 3. Or 4, 2, and 3 here. So this sees 8 or 9. You can see 1, 2, 3, 4, 5, 6, 7, 8. So it's definitely down there. This can't be 5 because of 5 in the row. So this is done there. This is not the same region as that. That's interesting. So if... I don't think this could be part of the same region. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, cannot be. So this has to be 3. So this is 3, and this must be 4. So this is done here as a boundary. And this yellow must go all the way down here. And if we try to have 7 here as a yellow, that does not work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this cannot be yellow. This must be part of pink. And it could be 1, 2, 3, 4. So we know we have guaranteed 1, 2, 3, 4, 5, 6, 7, and then 8 and 9. But it has to connect this way. So we have so 1, 2, 3, 4. We have to connect this way because we need to connect to this. 1, 2, 3, 4. Assuming we try to go this way, that doesn't work because that's 1, 2, 3, 4, 5, 6, 7, 8. And then this would be 9, but it's not orthogonally connected. So one of these two at least must be this way. So therefore it has to go all the way here. So we have 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4 it sees, 5, 6, and then this has to be part then. Because if it's not, that only sees 6 cells. So it has to go this way. We have 1, 2, 3, 4, 5. So this is 1, 2, 3, 4, 5, 6 cells it sees. 7, 8, and one of them has to be these two. So we have boundaries then everywhere else for the pink region. So these are boundaries, and one of these is pink. We're not sure which. This can't be 5. This can't be 4. There's a 4 in the column. This is 3 plus 2 adds up to 5. 3 plus 3 adds up to 6. 3 plus... Okay, this can't be 3 plus 4 adding up to 7 because that can't be 7. It can't be 5 here. So this has to be 5 or 6 here. This is 4. This must then add up to 9, and this must be 3 and 2. So we have to have 3 and 2 here. This cannot be 2. This can't be 3 anymore, so this must add up to at least 5. And this is 9. It cannot be the full 9 here because the red would be part of its region. So it has to be at least 8 and then 1 this way. It could be 1, 2, 3, 4, 5, 6, 7, 8, 9. But so this one has to be green also. This adds up to 9. It's 3, 6, and 4 as possibilities. So the boundaries for green have to be here because the 9 must see all the cells in this region. So we have 7 here. We have 2 out of these 3 left are the same region. This is 1. This cell cannot be green. It must be part of the light region here. This could be part of this region here. So that might be okay. This must be part of medium. And it cannot be the full 6 going this way, because if it's 1, 2, 3, 4, 5, 6, that's 8 cells, 9, 10. So this cannot be 6, which means this can't be 3. It could be, so it could be 1, 2, 3, 4, 5, 6, 7, 8, 9. That could be the case. Yellow has to essentially go in some sort of stepwise pattern here. So the yellow could be along here, or yellow could be along here, and that's it. Pink obviously has to be one of those two. Green could be any of these. So this is green, light, or medium. This is green or medium, and this is green or red. Obviously, this could be blue or orange or whatever. This cell can only see at... Okay, these are two separate regions. So it cannot be actually 6. It's blocked by the pink. So then this has to be 4. This sees 4 cells. It's either all medium or it's all dark. Which it could be. And this must be 1, 2 as a pair. Remaining digits in row 2 then have to be 3, 5, 6, 7, 8. Right. I mean, it could be 3 going down here, too. This can't be 3 because of 3 in the column. This is 1. Interesting. This can see either 2 yellows, so that would be 3. Or it can't be either part of this, and it must only see 6. So that would be, this is 3 or 6 here. Or it could be, it can't be 2. I mean, technically it could. No, it can't. If it sees only 2, then it goes that way, and then it does some weird stuff. And it can't be 1 and 5 adding up to 6. So this has to be 3. So this must be 3 that it sees. It could be seeing this, potentially. This is 2. It's probably the yellow, though. That would be my guess. Remaining digits in column 6, we have 1, 6, 7, 8, 9. But we have a 1, 2 pair in the pink region, so this can't be 1 or 2. We have 4, 6... Okay, this can't be 7. 4, 6, 8, 9 as the remaining digits in the pink region. One can't be here because of 1 in the row. This is 4. If we try to make it medium gray, we could have 1, 2, 3, 4, 5, 6, 7, 8. So that does work, unfortunately. Hmm. Oh, that means yellow definitely has to have borders here and here. Right? It only can find ways to connect, and that's it. Right? This can't be yellow. It cannot be pink. It cannot be some other region. Aha. So light and medium cannot be the same region. Because this cell, if they are the same region, what region is this part of? It can't be part of any region. It's blocked by pink and it's blocked by yellow. So these have to be light. So these are light. So that's guaranteed. This is at most 1, 2, 3, 4, 5, 6, 7. So this must be 8 and 9 at least for light. And it could go, light could go 1 more this way. So we have 8 lights here. And light can go 1 more this way. So then this is red or light. This could be red, light, or yellow. Obviously, any of these could be red. Okay, so how does this form a region? you have one of these two is, I guess this could be light. If this is light, how many cells do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 cells here. This cannot form two full regions. Therefore, what are the regions here? We can get 4 yellows here. Yeah, how many are... So 4 yellows here. That leaves 1, 2, 3, 4, 5... 1, 2, 3, 4, 5, 6... 7, 8, 9... This would be light and this would be green. I think it has to be, right? These can't be any other region. They have to be red, right? And this forms 9 cells as red. You can't have another region here because there's not enough cells that are, because they're blocked by yellow from extending. So these are the extra cells, which is 15, which can't form 2 regions. So the red can only be the only other region besides the ones that we have trickled in here. Well, if that's the case, these are the only ones which can be red. And that's 9 cells. So red cannot be any of the other cells. So therefore, we have a full boundary for red. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 cells for light. So this cannot be light here. And this can't be light here. That means we have a full 9 cells for yellow, which means none of these could be yellow. Well, this can't be light because we have the full light. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this must be guaranteed pink, which means this is not pink. So this has to be some sort of blue or something. So we have pink done as a region. We have yellow done as a region. We have light done as a region. One of these is guaranteed to be medium. Okay, this can't be 3 because of 3 in the box, in the region. We have guaranteed 1, 2, 3, 1, 2, 3, 4, 5, 6. So if we try to have this as pink, it could work, actually. 6, 7, 8, 9, that could work. So this is medium or it's dark. We don't know which. So these are medium and dark. This is dark or orange. These could technically be orange also. Can it, though? If these are all the same region. So say we try, it'd have to be at least 3 here. So that'd be 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. But then this doesn't have 5 cells that it sees horizontally and vertically. So orange cannot be part of this region. Therefore, this is its own separate region and must be blue. So this is not orange. This is blue. This then, it must be a 1 because it cannot go any other way. It's blocked there. This is not blue. And orange needs to get out somewhere. I guess, no, this is part... Dark is part of orange. Okay, so then... This is dark. Because it must see at least 5. So then this is dark. And not orange. I guess we could make this orange. Because it's not going to be... Yeah, and then we have blue and red, orange here. No. Maybe. We have... This is dark. This cannot be orange. But we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 cells. We need another 15, 16, 17, 18 cells to be full. So then this is, I guess we have blue, and this can't be orange. So this blue has to go all the way here, up to here, and these could be orange. So if we try to have blue here, this is too small of an orange region, so blue cannot be here. So this is orange. 1, 2, 4, 5, 6, 7. One of these. 1, 2, 1, 2, 3, 4, 5, 6, 7. And we could have 8, 9, or 8, 9. It cannot be 8 and 9 here, and it can't block off the blue. So this must be orange here, and this could be orange or blue. And we have some sort of scenario there. So this is done, which means this is a 5, and it sees that way. So this is 5, this is 2, this can't be 1 because of the 1 in the orange region. This is boundary. This is boundary. This sees 8 cells. So this is 8, which makes this 1 and 7 to add up to 8. This sees 5 cells, so this is not medium. So this is dark. So we have all dark here. This can't be orange. This is dark. So we have 1, 2, 3, 4, 5, 6, 7, 8. This cannot be full dark because then this was dark. This also sees 3 going this way because it cannot see 5. So this is 3 and 6. This can't be 3. This can't be 6. So it must go 3 here, and then this is not medium. It's done here, and this must see 4, so it cannot be dark. So these are all medium. Okay, so I think we have almost all the boundaries. We have 1, 2, 3, 4, 5, 6, 7, 8, and then one of these is 9. This can't be 8 because of 8 in the column. This can't be 5 or 7 because 5 or 7 in the column. This can't be 6 in the medium gray region because we have a 6 in the region. This can't be 6 because of 6 in the column. And we just have to do now irregular Sudoku. So this cannot be 4. It's 6, 8, or 9. This cannot be 1 or 2 because of 1 or 2 in the region. Where's the 1 or 2 in row 5? It has to be here and here. So this becomes 6, 8, or 9. Okay, 1. 1 cannot be in the dark region. So the 1 has to be in the blue region somewhere. Where is the 2? Remaining digits in yellow are 1, 6, 7, 8, 9. This can't be 1. These can't be 1 because of 1s in the row and the column. These can't be 7s because of 7 in the column. We're guaranteed... Okay, this can't be 1 because of 1 in the row. This can't be 8 because of 8 in the row. This can't be 7 or 8 because of 7 or 8 in the row. So this is 9, which means this can't be 9 here. And this can't be 9 here. Remaining digits are 4, 5, and 6 in row 3, with one of these being 5. This 9 eliminates 9 in the rest of column 6. We have a 6, 7, 8 triplet now, which eliminates 6, 7, 8 in the rest of the column. So this must be a 1 here. Remaining digits in medium are 2, 5, 7, and 8. This can't be 7 because of 7 in the column. No, 5 because of 5 in the column. Okay. Remaining digits in... This can't be 1 because of 1 in the column. Where's the 1 in the yellow region? It must be here. So that 1 eliminates 1 here, so this is 2 and 1. 2 cannot be here because of 2 in the column now. Where are the 1s? We need a 1 for red. Cannot be any of these 3, so 1 for red has to be one of these 2. We know 1 for blue. Cannot be here or here. 1 for blue has to be one of these 2. 1 for green cannot be here or here or here, so one of the ones for green has to be one of those 2. Therefore, since this is 1, this cannot be 1 here. That forces the red 1 to be there. Okay. 2s. 2 for... Where is the 2 for blue? Actually, where's the 2 for row 9? Cannot be here, cannot be here, cannot be here, so it has to be here. So this is 2, which makes this 1, which makes this a 2. So this can't be 1 anymore. This has to be 1 for the green there. So we have all the 1s, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. The 2s, we have 1, 2, 3. So where is the 2 in column 4? Can't be here because of the 2 in the box, or the region. Can't be here because 2 in the region. Can't be here for 2 in the regions. So it must be here. So this is 2. So we have all the 2s now. We now have to do 3s. 3 in red has to be one of these 2. 3 in dark cannot be here, and it cannot be here because of the 3 already in the row and the 3 in the column here, so this must be 3 here, which means this cannot be 3 here. Remaining digits of the dark region are 4, 6, 8, and 9. Okay. Well, 6 cannot be any of these, so this is a 4, 8, and 9 triplet, and can't be 8 here because of the 8 in the column. So this must be 6 here. So this is 6, which means this cannot be 6 here. This is a 4, 8, 9 triplet, which eliminates 4, 8, 9 in the rest of the row. This can't be 8. This is 5. That leaves this digit as a 7 here. This can no longer be 5 because of 5 in the region. Okay. The 4 or 9 must be in the blue region here. So one of these is 4 or 9. Remaining digits in column 8 are 4, 6, 8, 9 also. This can't be 6 because of 6 in the column. We need a 3 in orange. It cannot be here or here or here, so it must be here. Okay. Remaining digits in green. Well, actually, let's do column 1. Are 4, 5, 6, and 8. Okay. This can't be 5 or 6, so this is 4 or 8. Hmm. Right. This 5 eliminates 5 here. So this cannot be 5, whereas a 5 in row 3, it has to be here. That eliminates 5 from being here. We now have a 7-8, 7-8 pair in row 2, which eliminates 7-8 in the rest of the row. So this is 5 or 6, and we already have 5 and 6 in the gray. So this cannot be gray. This is green, which means this can't be green. This is gray. And we have the final region now. So this 7 eliminates 7 here, so it's 8, which makes this 7. This 5 or 6 cannot be anywhere here, so this must be 5 or 6 here. Huh. So let's just check. Okay, arrow points 3, 1, 2, 3 are in the same region. Arrow points 1, that's correct. Arrow points 4, 1, 2, 3, 4, same region. Points 2, 2 in the same region. Points 2, 2 in the same region. Points 1, 1 in the same region. Points 3, 3 in the same region. Points 1, 1 in the same region. This sees 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. This sees 7, 1, 2, 3, 4, 5, 6, 7. This sees 4, 1, 2, 3, 4. This sees 5, 1, 2, 3, 4, 5. This sees 8 through 8 there. This sees 3. So those are all set. We're guaranteed a 7 here. Where is the 7 then in column 7? Cannot be in orange because it's here. Can't be here because of 7 in the row. So this has to be a 7 here, which means this can't be 7 here or here. Remaining, this 8 eliminates 8 here. So we have a 4, 9, 4, 9 pair in row 1, which eliminates 4, 9 in the rest of the row. This can't be 4, 9, it's 8, which eliminates 8 here, and 8 here. Well, the blue cell here has to be 4 or 9 because to match that. So the 6 has to be in the orange here, which means this cannot be 6 here. So this is a 7-8 pair, which eliminates 7 and 8 in the rest of the column. This can't be 8. This is 6, which eliminates 6 here. So this is 4. That's 6. And this can't be 6 here. This can't be 4 here. This can't be 6 here because of a 6 in the row. So this must be 4, 9 with 5 here. Well, this can't be 5, so this has to be 5 here. That eliminates 5 from being here. Remaining digits in the light region. We have 3, 4, 7, 8, 9. And obviously these can't be 7 because of 7 in the column. So 7 has to be one of these two. We also have 3, 4, 7, 8, 9 in row 4. But this can't be 7 or 8, so this is 3, 4, or 9 here. 3 eliminates 3 as a possibility from being there. Remaining digits again, 3, 4, 8, and 9. But 8 in row 9 has to be in the red region, so this cannot be 8 here. Oh, whereas 8 in row 8 cannot be in the red region. These are filled out. This can't be 8 because of 8 in the column. This can't be 8 because of 8 in the column. So 8 has to be here, which means this is 8, this is 4. So this can't be 4, 8. This 4 eliminates 4 here, and 4 here. Whereas 4 in the light region, it has to be one of these two. So that eliminates 4 here. Six cannot be here because of 6 in the column. This is an 8, 9 pair, which eliminates 8 and 9 in the rest of the column. So now we have 3, 4, and 7 remaining. This can't be 3 and 7 because of 3 or 7 in the row, so this is 4, which eliminates 4 here. That means this can't be 4 here. Oh, we don't have all the regions set yet, right? Okay. 4 cannot be here because of 4 in the row. Okay, so one of those is 4. Okay, remaining digits in column. This can't be 3 because of 3 in the column. In column 3, 5 through 9. 5 through 9, no 7, no 8, no 5. Remaining digits in column 5 are 6, 8, and 9. Okay. So 5 has to be one of these in red. 7 has to be one of these two in red. This cannot be 3 or 7. It can't be 1, 2, 5, or 8. So this is 4, 6, or 9 here. This is 4, 6, 7, or 9. And this is 3, 4, 5, 6, 7, or 9. Okay. All the arrows and circles are bulbs are done. Okay, let's start marking 5, 6s, and 8, 9s, right? We're gonna mark this as A here, and this is B. So this must be the B here. And this must be A. Does that helpful? Not particularly right now. How about 8 and 9? C, D. This is D also. This is D also. D cannot be here or here. Or here. So then D has to be one of these two. So one of these is D. Not too helpful. Okay. Let's try E and F. E, F. That forces us to be F. F cannot be in the blue, so F has to be one of these two. Hmm. Is any of this helpful? Um. Huh. Not particularly, actually. Hmm. Yeah, this is just normal irregular Sudoku with a little bit of construction here. Um. I think we just have to try it, right? Hmm. Hmm. Ugh. Hmm. Uh, hmm. Um, hmm. Getting kind of stuck here. C has to be one of these two, but that doesn't really help us much. Right. I guess we just have to go down a path. I don't know. Not really liking that strategy. Huh. Uh. Huh. Hmm. Okay. If one, so one of column five has to have a six, and it has to be one of these two. If this is six, that makes this five, which makes that six. So neither of these can be six. If this is six, neither of these can be six. So this cannot be six here. We now have a 379 triplet, which eliminates 379 in the rest of the row. So this cannot be 9. It's a 4-6 pair. Is that helpful? I don't know. Maybe, maybe not. Um, huh. If, oh, that's interesting. If this is a 6, so one of these, also one of the yellows, one of these two is a 6. If this is a 6, that eliminates 6 from the blue region here. If this is 6, that makes that 5, which makes that 6, which eliminates, again, 6 here. So this can't be 6. This 379 triplet eliminates 379 in the rest of the red region, so this can't be 9. This is 5, 6, and 8, which eliminates 5, 6, and 8 in the rest of the row. So this can't be 6. This is 9, which means this cannot be 9 here. This is 4, 6 as a pair. Um, hmm. That's not helpful. Um, A then has to be one of these two. As 5 or 6, but that's not helpful. Um, 8 is one of these two. Is that helpful? Not particularly. Okay. Hmm. uh, hmm. Oh. We have a guaranteed 8 in orange and a guaranteed 8 in yellow. That eliminates 8 from the rest of rows. And that's guaranteed in row 6 and row 7. So that means we cannot have another 8 in row 6 and row 7. This cannot be 8. We have a 3, 4, 9 triplet in column 2, which eliminates 3, 4, 9 in the rest of the column. So this cannot be 9. All the D's are 8. And we don't know which of these D's are here. Actually, it has to be here, right? So these are all D's. They have to be 8 because of the 3, 4, 9 triplet in column 2. So this is 8, which makes C a 9. This cannot be 8 here. This cannot be 8 here. So that makes this 6. This is 9. So B is a 5. So B has to be 5. A has to be 6. So this is 6. Okay, which means this can't be 6. This is 4, which makes this 6. 4 eliminates 4 here, so this is 9. And 9 has to be part of the blue. So this is blue, which means this cannot be blue. It's orange. So this is done as a region. This 6 eliminates 6 here, so it's 4. This can't be, this 9 eliminates 9 here, so it's 3, which makes this 7 and 9. 7 eliminates 7 here, so it's 3, which makes this 9, which makes that 7. This can't be 8 or 9, it's 6. This can't be 9, this can't be 9, so it's 4, which makes this 3. 4 eliminates 4 here, so it's 9. 8 eliminates 8 here, so it's 7 and 8. 9 eliminates 9 here, so it's 4. The remaining digit here is a 7. Remaining digit here is a 5. And that's a solution. Yeah, I just kind of got stuck with the irregular region Sudoku, but eventually I got there. Yeah, I'm not too used to. I mean, I've done a decent amount of like chaos construction, so I should be decent at irregular region Sudoku, but sometimes I just don't see it. And it took me a while to see this. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.